Hi, this is King of Review. Here we are told that 1 cubed plus 2 cubed plus 3 cubed all the way up to k cubed is equal to 1/4 k squared times k plus 1 squared. And we're asked to use that to simplify or to prove whether the very same series with one more term added on, k plus 1 cubed, is equal to this new expression, 1/4 times k plus 1 squared times k plus 2 squared. Well, let's start with what we know. We know 1 cubed plus 2 cubed plus 3 cubed all the way up to k cubed is equal to 1/4 k squared times k plus 1 squared. And we are looking at the series, the same series with this one extra term added on, k plus 1 cubed. So let's add that term on to the left side. Of course, to keep this equation true, we have to add it on to the right side as well. Now, the left side of our equation is the series we're looking to prove. So all we need to do is figure out if the right side does equal the expression we're trying to prove that it equals. So let's see what we can do with the right side of this equation. 1/4 k squared times k plus 1 squared plus k plus 1 cubed. So we have two terms here, and they both have some things in common. They both have k plus 1 squared, since k plus 1 cubed is just k plus 1 squared times a third k plus 1. I'd like to factor out k plus 1 squared to try to simplify things a little. If we factor out a k plus 1 squared from both terms, we're left with 1/4 k squared from the first term, and from the second term we're just left with that third k plus 1. Now, we know what we're looking for has a 1/4 in front. And there's a 1/4 here in this second polynomial, so let's factor that 1/4 out so that we can get something that looks like the answer we're looking for. 1/4, the k plus 1 squared I'm leaving alone, and now if we divide by 1/4, that's the same thing as multiplying by 4. So I'm going to multiply all these terms by 4 to show that I've factored out 1/4. 1/4 k squared becomes k squared, k becomes 4k, and 1 becomes 4. Now, this is almost exactly what we want, except what we want has k plus 2 squared instead of this polynomial at the end. Let's think about k plus 2 squared for a minute. That's the same thing as k plus 2 times k plus 2. If we distribute, we get k squared. 2 times k is 2k, k times 2 is 2k, 2k plus 2k is 4k, and 2 times 2 is 4. And lo and behold, we get exactly the polynomial that we have here in our problem. So we just showed that this problem is the same as 1/4 times k plus 1 squared times k plus 2 squared, which is exactly the expression we were looking to prove. So this equation is true. Thanks for watching.